Assalamualaikum and hi. My name is Siti Khadijah binti Khairul Imran. So today I'm going to tell you guys about the introduction of this experiment. First of all, the title for this experiment is Gravimetric Methods for Determination of Chloride in Soluble Salt. The use of the silver nitride is to form the precipitate of silver chloride. Gravimetrically determine the amount of chloride present in the sample. Any inorganic compound containing halogen can be made into aqueous solution and treated by silver nitride to obtain the precipitate of the silver halide. The chloride content of a soluble salt can be determined by precipitation of the silver chloride. The precipitate can be collected more easily if the reaction solution is heated before filtering. This causes the solid silver chloride particles to coagulate. The precipitation is carried out under acidic conditions to avoid possible errors due to the presence of the carbonate and phosphate ions, which could also precipitate with the silver ions. This experiment also aimed to determine the chloride content in a flour sample by employing gravimetric analysis, which is a technique that allows for precise measurement of a specific ions through precipitation. Flour is a common food product with various mineral contents, including sodium chloride, which contributes to its overall sodium levels and flavor. Understanding the NaCl content in flour is important for nutritional labeling, quality control, and dietary consideration. The experiment demonstrates the application of gravimetric analysis in food science to assess specific ion concentrations based on chemical reactions and stoichiometry. That's all from me, thank you, and I will pass to my next member.
Okay, let's look at the objective of the experiment. Okay, first to apply the gravimetric analysis to quantitatively determine the amount of chloride in sample. Second is to recognize and apply the concept of stoichiometry.
The chemical and the apparatus that was used in this experiment was sodium chloride, silver nitrate solution, concentrated nitric acid, ammonium hydroxide, commercial shower gel, commercial flour, beaker, heated funnel, heating plate, graduated cylinder, filter paper, aluminum foil, analytical balance, oven, and lastly vesicle.
Hi, Assalamualaikum. So next we are going to go through the methodology part. So for part B, which is the determination of chloride in soluble salt, there are 10 steps. Okay, so for the first for the first steps, two 400 milliliter beaker and two filtered funnels were cleaned, dried, and labeled. Next, by using the analytical balance, 0.5 grams of sodium chloride salt were weighed and dissolved in 100 ml of the ionized water in each beaker. The third is slowly with continuous stirring. 0.2 mole of silver nitrate were added to each beaker until the coagulation of silver chloride was observed. Next, 6 ml of 6 mole of nitric acid to each beaker were added. The fifth step is the mixtures in the beakers are heated to digest the solution for 10 minutes. The sixth step is a small volume of silver nitrate were added periodically while heating the beakers until the solution stopped becoming cloudy upon the addition of silver nitrate, confirming that the reaction was complete. Next, the precipitate of each beaker were filtered through the pre-weighed fitted funnel. The precipitates are washed 8 times with deionized water mixed with 0.5 of 6 mole nitric acid, which is, to be precise, is 1 milliliter concentrated nitric acid in 200 ml of deionized water. Next, the funnels were wrapped along with their contents with aluminium foil and placed in the oven at 120 degrees for 90 minutes. Next, the funnels were taken out from the oven and placed it in the desiccators to cool to room temperature. And the last step is the mass of the filtered funnels were determined and their respective contents by using analytical balance and subtracting the weight of filtered funnels from that of filtered funnel and its contents combined. Okay, so I think that's all from me for part A and part B. Next, for the next part, I will pass it to the next presenter. Thank you. So, we have done part C, which is the determination of chloride in commercial flour. So, okay. So, part C, there are 15 steps. So, for the first step, 5 grams of flour were weighed exactly using an analytical balance. The flour was transferred into a 100 ml beaker. 50 milliliters of distilled water were added to the beaker and stir the mixture thoroughly to dissolve sodium chloride present in the flour. And uh, let the solution sit for about 30 minutes to ensure full uh, dissolution of the salt. Next, the mixture was filtered to remove the solid residue of flour using filter paper. And then we are going to collect the filtrate, which contains dissolved sodium chloride in a clean beaker. Next, if the sample contains organic materials or carbonates, a few drops of nitric acid were added to filtrate to the filtrate to prevent precipitation of other unwanted salts, especially carbonates or phosphates. So the next step, 50 ml of distilled water was added to the filtered solution to dilute it further. And then the solution was heated gently on a hot plate to about 60 until 70 degrees Celsius. And then and then we are going to slowly add the silver nitrate solution, which is zero point 0.1 mole, dropwise while stirring constantly. A white precipitate of silver chloride form immediately as chloride ions react with the silver ions. And then the silver nitrate, we are going to continually add it until no further precipitate forms. This ensures that all chloride ions have reacted by adding a few more drops of silver nitrate and until no new precipitate is formed for checking. So a Bachner funnel with filter paper was set up and connected to a vacuum filtration apparatus. The solution was filtered uh, to collect the silver nitrate precipitate on the filter paper. Okay, so for the five last steps, the precipitate was washed with small portions of distilled water to remove any remaining sodium nitrate or excess silver nitrate. And after washing, the filter paper was transferred with the precipitate to a drying oven. The filter paper was dried with silver chloride in a drying oven at 105 degrees Celsius for around 1 until 2 hours. And after drying, the filter paper and precipitate were allowed to cool in a desiccator to prevent absorption of moisture from the air. Once the precipitate has cooled, the filter paper will weighed along with the silver chloride precipitate using the analytical balance. And then lastly, the mass of the dried precipitate of AgCl filter plus filter paper were recorded and the mass of the filter paper alone were subtracted to obtain the mass of precipitate of uh, AgCl. Okay, that's it for me. So for the next slide, I will pass it to the next presenter. Thank you.
Alright, I'm Sita Haja. In this video, I just wanna explain about the result and discussion. Alright, first, determination of chloride in soluble salt. We run two times in this part, which is for the first data, we got the mass of AgCl precipitate is 1.8533 gram, and the second data we get 1.81
1.54. The observation of for this color is greenish purple. And then this is for calculate the mass of chlorine. For the first data, by using this formula, moles of AgCl equal to mass of AgCl divided by molar mass. By substitute the data, 1.8533 gram divided by 143.32 gram per mole, 0.0129 mole of AgCl get. And then by using this equation, which is Ag plus in aqueous solution and Cl minus in aqueous solution, and then the AgCl was precipitate. By using a stoichiometry, the mole of chlorine is 0.0129, and then we use this formula to calculate the mass of chlorine, which is moles of chlorine equal to mass of chlorine divided by molar mass. We get the mass of chlorine is 0.4573 gram. Alright, this is for the second data. By using the same step, the mass of chlorine is 0.4502 gram. And then move to the determination of chloride in fluor, which is part C. The experiment encountered a few sources of error and notable observation that may have impacted the result. One key source of error was the potential for excessive dilution, as 50 ml of distilled water was added. This dilution might have reduced the concentration of sodium chloride in the solution, affecting the formation and precipitation of silver chloride. Additionally, during the addition of silver nitrate, an initial cloudy appearance was observed, indicating the beginning of AgCl precipitation. However, as the experiment progressed, the solution turned brown, likely due to the over-addition of AgNO3. Excess AgNO3 can lead to side reaction or decomposition product, particularly in the presence of light, which might contribute to the observed color change and interfere with the final precipitate mass.
At the end of the experiment, the silver chloride does not precipitate as they expected. The possibility why it doesn't precipitate may be because of the concentration of chloride in the flour is low below the detection threshold. Other than that, the interference from other components in flour such as proteins and iron phosphate that can interact with silver ions and inhibit the formation of silver chloride. Without precipitate, the stoichiometric basis for determining an AgCl content through AgCl mass is undermined.
And then this is for determine the coefficient of variation of the data. First, calculate the mean, which is 1.8533 plus 1.8154 divided by 2. We get the mean is 1.8343. And then second is calculate the variance and standard deviation. By using this formula, the variance is 0.7530 exponent negative 3, and then calculate the standard deviation by square root the variance, and then the standard deviation is 0.0274. And the last one is calculate the coefficient of variation. Coefficient of variance equal to standard deviation divided by mean times with 100, and then the coefficient of variance is 1.49%.
Relate with the technique of gravimetric analysis to the concept of stoichiometry. The mass of silver chloride AgCl, which is produced when silver nitrate AgNO3 interact with chloride ion Cl-, can be measured using stoichiometry in gravimetric analysis to determine the chloride content. The precise measurement of chloride concentration based on molar mass of AgCl is guaranteed by the stoichiometric ratio 1:1 between Ag plus and Cl minus. How the experiment can be applied in industry. So for the first industry is food industry, which because chloride determination is essential for measuring sodium chloride level in product like a flour, bread, and processed food. Salt concentration impact the flavor, preservation, and health compliance of food product. Using gravimetric method, industry can control the chloride level to meet regulatory standard and ensure consistent product quality. And for the second industry is pharmaceutical. Chloride content in a raw material, excipient or active ingredient can influence the stability and efficacy of drug. In pharmaceutical, gravimetric analysis is used to ensure that the chloride content is within acceptable limit, which help maintain the purity of compound and avoid reaction they may. I will determine the gravimetric factor, which is the formula for the gravimetric factor is gravimetric factor equal formula weight for Cl over formula weight for AgCl. So Cl is 35.453 and for AgCl 143.32. So the final answer for gravimetric factor is 0.24737. Calculate the sodium content in the original 5-gram flour or shower gel sample by using the relationship between NaCl and sodium 22.99 gram per mole. Use the mass of silver chloride AgCl to calculate the chloride content. The molar mass of AgCl is 143.32 gram per mole and sodium chloride NaCl is 58.44 gram per mole. So for this question, due to a few mistakes that most likely happened during the experiment, we were unable to obtain the silver chloride AgCl precipitate. So the mistake are high concentration of chloride solution, excessive heating of solution, and inadequate cooling before filtration.
For the conclusion, the experiment explained the challenges in determining chloride in a both soluble salt and complex sample, like a commercial flour. In soluble salt, silver chloride precipitation occur as expected. This confirms the chloride presence. However, in the flour, there are excessive dilution and interference from the protein and phosphate, likely hindered silver chloride formation, while the excess of silver nitrate lead to discoloration. This suggests the site of reaction. This also highlights the needs for careful reagent control and consideration of sample composition for accurate chloride quantification in a complex mixture. That's all from us. Thank you.